Nanoscience is the science of the incredibly small, everything just outside the realm of quantum physics. That is everything larger than the smallest size possible, which is h bar over 2 pi. Nanotechnology is the pathway to the future, the next age of man. As we enter the transition point between the information age and the nanotech age, we are reminded that we are living in what is probably the most difficult and amazing step in human progress of all time. Alien nanotechnology would be thousands of years more advanced than our own. They are at the point where they can build things atom by atom. This is called nanoengineering, and it can be used to build anything you want to build, as small as it can be built. Motors, refrigerators, computers, gears, circuits, you name it. Nanotechnology can also be applied to material science and materials engineering. The ultra-smooth, ultra-durable foil that was reportedly found in the debris at Roswell by Jesse Marcel and a few others, it's this ultra-thin foil that they crinkled up into a ball, and then when you let it rest, it would uncrinkle itself, becoming mirror smooth again with no signs of damage, and you couldn't cut it with a pocket knife. This is another example of a nano-engineered material. To create a thin film with these characteristics, you would need to manufacture a material with nanomechanical properties, which would allow it to bend and fold completely in half without breaking any chemical bonds. It's basically a mechanical crystal, a crystal which is built out of nanolevers and nanosprings that can bend and flex at the molecular level without breaking. Chemical bonding is what holds atoms together. This is the reason that all these tiny atoms in the universe don't just fall apart. They stick together and form solids due to the electromagnetic interactions of different atoms. Try to think of atoms as tiny magnets, but not regular magnets with a north and south pole. These magnets work on a different set of rules based on the filling of electron orbits, the Lewis structure. Nonetheless, you can think of them as tiny magnets. Some are strong magnets and some are weak magnets. The stronger the magnet, the stronger the bond, and the stronger the bonds that make up a material, the stronger that material will be. What is in many ways equally important is the structure and arrangement of atoms in a solid. Crystals, which have an ordered structure, tend to be very strong because of their structure. A diamond, for example, was the strongest material known to man. Diamond has fourfold tetrahedral symmetry, which is extremely rigid because the chemical bonding of the carbon atoms combined with the distribution of forces within the crystal lattice structure. These strong chemical bonds and the lattice structure allow forces to be distributed and absorbed to an astounding degree. The strongest grid structure found in nature is the hexagon of a bee's honeycomb. Spongy bone tissue is a way to combine strength and with light weight. The material we're going to talk about has all these characteristics. The hexagon of a bee's honeycomb has six-fold symmetry. Diamond has four-fold symmetry, but this nano-engineered super material, which we're going to talk about next, and which the aliens use for the skeleton of their craft, has 12-fold symmetry. 12 is divisible by both 6 and 4, combining the two strongest symmetries in nature. The material must be made in the zero-gravity atmosphere of outer space, where gravity can't mess up the surface gradient, causing crystalline deformation. You have to basically form the crystal using flux growth technique, gradient freeze methods. The crystals are formed in bubbles of diverging sizes, larger bubbles toward the center of the material and smaller bubbles toward the surface of the material. That way it mimics the strength and lightweight characteristics of spongy bone. The diverging bubble size optimizes the strength and weight of the material. In this case, it custom nano-engineered it for use in spacecraft, aerospacecraft. The material is strongest at the surface where the bubbles are the smallest. It is literally 11 times harder than diamond at the surface, down to about 5 times harder than diamond at the center where the bubbles are larger. This material is used to make the shell or skeleton of the craft. This is the material that was described as the bakelite debris found at Roswell. It is formed by a laser-enhanced growth process using sinusoidally polarized electromagnetic waves to trap and cool the atoms individually, adhering them to the correct position within the crystal's lattice structure. MIT's already developed a tractor beam which can move around atoms and place them individually. This is basically what they have. They have a million of these things going at once, which grow the crystals during the phase change from Well, crystals always grow during the phase change from either liquid to solid, which is called freezing or point of fusion, or when a gas turns to a solid, sublimation. Crystals can also be grown from dissolved particles in a solvent when you evaporate the solvent, but that's not how we're going to grow these specific type of crystals. The most commonly used crystal growing technology in use today is the flux growth technique, where they use magnetic field lines to propagate crystal growth. Basically, the crystals will grow along and follow the magnetic field lines. However, current technologies can't achieve the accuracy to produce a perfect crystal, with absolutely no deformities, imperfections, or any irregularities whatsoever within the crystalline lattice structure. Nature can't even produce this. But nanoengineering can, and when it does, it produces things that are 11 times harder than diamond. See, diamond has all its weaknesses and the imperfections in the crystal structure, so when it breaks along the lines of these imperfections. So if you were to build a diamond with no imperfections, it would be harder than regular diamond even. As for physicist Bob Lazar is absolutely correct when he stated that everything in these machines is engineered to the utmost perfection. Nano-engineered would be a better word for it. Unfortunately, that's one of the only things that Bob Lazar got right. You see, what is often done in highly secretive, compartmentalized black operations, such as the kind of back engineering research that goes on at Area 51, it is a common practice to feed individuals involved a great deal of misinformation or disinformation, which is unrelated to the individual's specific line of study. So if you were contracted to back engineer the propulsion systems, you would be fed all sorts of disinformation about all the other systems and workings of the craft. So in case you ever went public with any information, you could be discredited and used to relay more disinformation to the public from a seemingly credible source. It's one of the things they use. They're very, 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 very secretive. It is absolutely imperative that you understand that A, we are not alone, and B, there is a massive government effort to keep the truth covered up. And with aliens, it's not very hard because they make themselves scarce, and it's pretty much ridiculed by people who don't have a brain to really sit and think about this kind of stuff. So I've just described for you some of the methods that they use to hide and disguise the truth. This is what has allowed them to get away with it for so long. That combined with the total unwillingness of certain people to accept the truth. If you don't believe me, go look up military classification and read the definitions of top secret and above top secret. It will tell you exactly why the government doesn't tell us the truth. I figured if you're watching this video, then you're obviously at least looking for the truth. We should never stop looking for the truth. So please ask questions, point out any flaws or corrections. Don't forget to rate 5 stars and subscribe to my channel in order to help spread this information faster. I have plenty more videos to come.